Hi Jay, I got your work. Thank you. I've altered your grade. I've updated it. All the work you sent me was correct. It was very nice. So thank you. Also, your handwriting is just lovely. It's very easy to grade your papers. I appreciate that. Okay, so I had gotten up to letter H with you, and you sent me what was missing from your exam. Number 3 was correct. So we don't need to go over that. But number 4, we have a mistake. So let me see. I gave a -2 on this. Let me see if I can find it. Okay, so I had asked you in lecture, you have 2 of the 3 parts I had asked you for. And I see that you said it's continuous. I see that you found the output values. But I asked you guys in the 3rd part to say that I know I have an 11 because I'm using the intermediate value theorem, which guarantees I have all the intermediate values. So you sort of wrote it as like, oh, okay, so F is 11. You have to say we know F is 11 because the intermediate value theorem guarantees that it is. So you didn't sort of like invoke that piece, that 3rd piece. Okay, number 5 is good. Number 6, okay, so a couple parts there we got to look at. I have to juggle like 3 things at once when I do this. This is like a multitasker's dream here, which I'm not. Okay, so let me just eyeball what you got here. So you got letter A right. That is correct. Okay, letter B. That is a stepwise function. So that's like a bunch of stairs. That looks like a bunch of stairs. So like when you draw something like that, let me see. This one is pushed over to the, I'm just looking at what you wrote. This one's actually pushed to the left. So this is like a bunch of stairs. So it has, oops, I missed a spot there. Okay, hold on. I keep hitting my keyboard, which is annoying to me. Okay. This is a bunch of stairs, this function, this y equals to greatest integer x plus 4. It's a bunch of stairs shifted to the left. And so every time you hit an integer, you have a gap. Every time you hit an integer, you have a gap. So that's what you need to say for this. So let me just find it in my notes so I can show you how I wrote it. Okay. All right. Discontinuous at every integer. No, I'm looking at the wrong thing. Discontinuous, which, okay, am I losing it? Part C. I am usually losing it, so. Okay, here we go again. Discontinuous at every integer. I don't know why I wrote this part here. I must have carried this down from the previous line. Okay, discontinuous at every integer, non-removable, because you have these infinite amount of gaps. Infinite, because at each step you have a gap. Okay, so that was, all right, so I gave you part C. I should have given you part B first. All right, so that was the answer to part C. It's not continuous. It's discontinuous at every integer, non-removable because it's a gap. Okay, this one, part B, is not continuous as well because if you drew these 2 functions together, they make a gap. Let me just see if my brain can put that together real fast for you. Okay, the first function, x plus 5, that's going to look something like this. At 2, it's going to be at a height of 7, and it's at 2, it's going to be at a height of 7, and it's open. I'm just rough sketching this for you. Okay, so that's the line. Then it's here, so at 2, it's 6. So at 2, this guy is 6. It's below this guy. It's closed. And it's also a positive slope, but real sharp. Okay. I just totally rough sketching this. So these graphs don't connect. The top graph's at a height of 7, the bottom graph's at a height of 6. It's not connecting. So you want to say that at 2, it's not connecting, it's non-removable, it's a gap. All right, these graphs here, right, don't snap together. They're not continuous. Continuous would mean that you go from one graph right into the other graph. You go from one graph right into the other graph, and you can draw it in one swing. You don't have to pull your pencil off the paper. This, I'd have to stop here, pull my pencil up, and keep going. Right? This is. I wouldn't want to ride on this if this was a roller coaster. I'm not going on it, right? Because right here, that part's. I do know some people personally that would want to ride that, but not me, right? Because you're gonna fall. You're gonna fall right here. That's not gonna be fun, at least for me. All right, let me see what else here. So part D didn't go well. Let me see what part D was. Okay, part D is not continuous. I can see you factored this here, which is correct. This is a correct step, but you have to remember when you have common factors, that makes a whole. That makes a whole. So what is happening here is you have actually a line, and at -3, the common factors make a whole. So when x is -3 here, this graph is not defined. So what you want to write for that, see at this common factor, you want to say that that's removable because it's a whole. All right, but it's not continuous. That again is a roller coaster I would not want to ride. Right, because you get to this spot and there's no track here. Again, I probably do know some people that would enjoy that, but that wouldn't be me. Okay, and then letter E. Letter E, it is discontinuous, non-removable. You had to figure out where, right? So you write first this as a reciprocal identity. The cosine is equal to 0 at pi/2 and 3 pi/2 on the first swing through. And then you have to counteract that the function's sped up. So once you first figure out all the coterminal angles, they start at pi/2, right? And you add pi to get to the next one. That's me adding pi to get to the next one, right? Use pi/2, 3 pi/2, 5 pi/2, 7 pi/2, right? It keeps going around. And then the next step, you have to divide off the 2 to both parts. And that's non-removable because these are vertical asymptotes. Okay, that's it. That is your exam. I'll catch you. I hope that helped. Bye-bye.